Good afternoon, and thank you all for being with us here today, both in person and also online virtually. We have an extremely exciting event today, but before we begin, I just want to point out that the primary exit for the building is just the way you came in, and that if there's any kind of fire or other emergency, that's the way you should go out and not use the elevators. So myself, I'm Greg Allen. I'm the director of the AI Governance Project here at CSIS, and have the privilege of introducing our two speakers, both of whom I had the privilege of working with at the Department of Defense not too long ago. So to begin, Nand Mulchandani is the inaugural Chief Technology Officer of the United States Central Intelligence Agency, better known as the CIA. Prior to joining the CIA, he served as the CTO and acting director of the Department of Defense Joint Artificial Intelligence Center. He also co-founded and was CEO of several successful startups: Oblix, acquired by Oracle; Determina, acquired by VMware; OpenDNS, acquired by Cisco; and ScaleExtreme, acquired by Citrix. He has a bachelor's degree in computer science and math from Cornell, a master of science and management from Stanford, and a master in public administration from Harvard. And our second speaker, Lieutenant General Jack Shanahan, retired as the Lieutenant General in the United States Air Force. From 2018 to 2020, he served as the inaugural director of the Department of Defense Joint Artificial Intelligence Center. Prior to leading the JAIC, he led the creation of the Algorithmic Warfare Cross-Functional Team, aka Project Maven, as the Director of Defense Intelligence Warfighter Support in the Office of the Undersecretary of Defense for Intelligence. Over his 36 years of service in the United States Air Force, Lieutenant General Shanahan accumulated more than 2,800 flight hours and flew F-4D, E, G, F-15E, and RC-135 aircraft. He's a graduate of the University of Michigan, the Naval War College, the National War College, and North Carolina State University. Please join me in welcoming both of our speakers. And they're here today to discuss the publication by CSIS of their report, Software-Defined Warfare, which contains a great number of their insights from their careers across the public and private sectors. So to begin, I'd like to turn it over to Lieutenant General Shanahan, who'll begin with some remarks, and then Nand will also have some opening remarks, and then we'll move to the moderated discussion. Thanks very much.
Well, thank you. Good afternoon to everybody physically present and also online. First time the three of us have been together again since the JAIC days. And Greg was the Director of Policy and Strategy at the Joint Artificial Intelligence Center. I know we're here today to talk tech, and Nand will get pretty deep into technology. But what I don't want to do is lose track of what Greg accomplished in that role at the JAIC. The tech is the backdrop, but trying to understand how the Department of Defense moves forward with artificial intelligence, machine learning, and various subsets therein is a big thing. It's a big change for the Department of Defense. What are the policies? What are AI ethics? What is responsible AI? What is test and evaluation? What are our partnerships and coalitions need to look like when we start working with governments of other agencies? Greg did all of that as the Director of Policy and Strategy, including playing a very, very important role in writing the DoD AI strategy. But more importantly than writing the strategy is the harder part of implementing the strategy. So to say that the three of us had a close relationship wouldn't be fair. It wouldn't do justice to the relationship we had to have, that it was all combined together between the technology, the strategy, the policy. Those of you who have heard of DoD 3000.09, autonomy and weapon systems. That is now being revised, and I can promise you that some of the revisions that we'll see come as a result of some very in-depth conversations that we had when we were together at the JAIC. So I'll just get into it and talk about their two seminal moments that I had before the end of my time in uniform, both of which completely changed how I viewed AI ML adoption in the Department of Defense. And to be fair, the first one was less of a seminal moment and more of a seminal experience over the course of the first year when we embarked on the Project Maven journey beginning in late 2016. And that was framed by three things. It may seem a little odd. One of them was a book, one of them was a New York Times article, and the third was a movie. The book was Gary Kasparov's book, Deep Thinking, about his chess losses to Deep Blue, 1996 to 1997. Really set the stage for thinking about AI. The The second was a New York Times article that came out in December in 2016 titled The Great Awakening. And it was really about how machine learning completely changed how Google Translate worked. And the third, the movie, was AlphaGo, the movie, about the now famous matches between AlphaGo and the world champion and Go master Lee Sedol. Those three provided a backdrop of the journey that I began in Project Maven. And the moment we started Project Maven, every day became an eye-opener to me as I learned about the AI ML world that existed in commercial industry, that had existed in commercial industry for many years, included all the software industry best practices that were critical to developing, fielding, and sustaining AI-enabled solutions. Computer vision, natural language processing, agile, user-centered design or UI/UX, CI/CD, PaaS, SaaS, Docker, containerization, virtualization, APIs, REST, JSON, microservices, CNNs, RNNs, LSTMs, which are now our transformers and diffusion models, data management pipelines, AI-T&E, GPUs, TPUs, MVPs, GANs, and so on. Never mind the strange vocabulary. This entire world did not resemble the world all of us have been exposed to during our respective military careers up to that point. But everyone in Project Maven knew that that world represented our future and also represented the future of the Department of Defense. It's not that elements of this world didn't exist in DoD back then. They did. But it was mostly in the service research laboratories. And it was never all together. Even in those rare instances, when many of the elements existed, they could not be combined in ways that would allow organizations to bring AI-enabled solutions at speed and, more importantly, at scale across the Department of Defense. My learning curve was very, very steep during that first year of Project Maven. The second seminal moment, and this really is a seminal moment, happened when Nand accepted my offer to be the JAIC's first Chief Technology Officer or CTO. How we connected is a fascinating story of serendipity by itself, but that's for another time and another conversation. As much as we thought we knew about commercial software best practices by the end of our second year in Maven, we were still amateurs. And by that point, Maven was way ahead of where we were in the JAIC when it launched, since with the exception of me and just a couple of other people who came over from Maven, we didn't have the benefit of Maven's experiences, which were all learned the hard way. Nand was a professional, the real deal. His 26 years plus of Silicon Valley commercial tech experiences were instrumental to shaping everything that we did in the JAIC. And I'm not being dramatic at all when I'll say that my world, and the entire JAIC's world, changed immediately and irreversibly the day Nand arrived at the JAIC. What followed was many, many whiteboard sessions and intense discussions about what we needed to do in the JAIC to bring AI in speed and scale across the Department of Defense. We talked about horizontal versus vertical scaling, marginal and total cost, pets versus cattle, platforms, API calls, modular architectures, and a lot more, all the things that you're going to find in the paper. And he also gave this example of a restaurant in San Francisco called Cafe Jacqueline. It's a famous restaurant, apparently, very small. All they do is soufflés. And the person that owns it, who runs it, who makes the soufflés, is a fairly elderly lady, French. They only have so many tables, like 15 total tables. They can only take reservations for about 2 hours and they shut down. And he kept using this as an example, as there's no scaling to be had in Cafe Jacqueline. She's never getting better at marginal cost. She has total costs that keep going up because of inflation, but all she can do is keep putting out so many soufflés, and when she says it's done, it's done. The place closes. A few months ago, I took a trip to the West Coast, and Nand took me to Cafe Jacqueline. It is exactly as he described. And if you go there, do not screw around with the maitre d'. He will boot you out the door faster than anything. But that really put to me some of the basic principles that Nand was getting at, strangely as that may sound. Nand said, I love Cafe Jacqueline. I will keep going back there when I can get a reservation. But the DoD cannot become Cafe Jacqueline. It won't work. And more importantly, Nand helped shift the collective mindset in the JAIC to thinking about tech as a weapon system, not merely as an IT enabler for everything else that was happening across the Department of Defense. It didn't take very long at all for Nand to learn the DoD's niche vocabulary. He taught me how to speak software. I connected him with military operators and helped him learn to speak JADC2, which, by the way, he now speaks with a level of fluency better than most senior people in the Pentagon. We both understood the imperative of helping the DoD make the shift from an industrial age, hardware-centric organization to a digital age, information or software-centric, more risk-tolerant one. After only a few months in the JAIC, once he learned the lingo and gained a deeper understanding of the operational requirements that call for AI/ML solutions, Nand would come into my office and tell me the same thing again and again. General, I know how important AI is to the DoD. It's critical to future warfighting. I get that. But the department has a much bigger problem, a much bigger fish to fry. It's architecture. It won't work for what we're trying to do. We will never get AI and ML right if we don't fix the underlying architecture. So after leaving the department and before taking his current position, Nan was able to put in print what he'd been thinking about for probably the last 5 years. And once he had a good first draft, he asked me to join as co-author, which of course I jumped on the opportunity immediately. And that led to the paper that we're talking about this afternoon, Software-Defined Warfare, Architecting the DoD's Transition to the Digital Age. Why is this paper so important to the Defense Department? Beyond that is the obvious call for aligning DoD with commercial industry software best practices. Well, in future crises and conflicts, the side that adapts faster and demonstrates the greatest agility to include rapidly updating fielded software and AI models may well gain a significant tactical and operational advantage. As I said just a moment ago, the DoD will never gain the full competitive advantages that come with AI and ML-enabled solutions if it maintains the same architecture that was optimized for a different time and a different mindset of an industrial age department. Don't just take our word for it. In the chapter on defense in the forthcoming Strategic Competitive Studies Project report that's titled Mid-Decade Challenges to National Competitiveness, there is a section in there titled Gain and Maintain Software Advantage. Now, that report's embargoed until it's released a week from this Friday, but I contest the language in this section of the SCSP report is very closely aligned with the words in our paper. And I'll just use one quote. A military's ability to deploy, employ, and update software, including AI models, faster than its adversaries is likely to become one of the greatest determining factors in relative military strength, end quote. That is a bold and powerful statement. And then the last thing I'll say before I turn it over to Nand is that we're not claiming that this paper is a quote-unquote recipe for architecture success in the DoD. That is a banal statement that makes it sound far too easy. We know it's not easy. It's not a cookbook. What it offers, however, is a feasible path forward, a framework or a blueprint with a lot of concrete, tangible recommendations that, if implemented, will help accelerate DoD's transition into the digital age and make it better prepare for a future fight against a peer competitor. So with that said, Nand, I will turn it over to you. Thank you.
Hello, everyone. Well, I'm going to start by saying that I can't thank you enough for all the great things and you said about me. I did not know you were going to give me that level of an introduction. Otherwise, it's very embarrassing. And it's also really, really hard following your boss or former boss. And, you know, General Shanahan is one of those amazing individuals who took a chance on a recent grad with no experience at all with any of the acronyms or warfighting or having actually even been to the Pentagon. Actually, that was the first time I met you. And I can't thank you enough. I mean, my career so far in Washington, obviously all these concepts and everything, and the ability to serve has been primarily because of this man. So anyways, and also thanks to Greg, who, you know, it's great having the band back together, at least for one time. All these whiteboard discussions, and I tend to use slides. Actually, I think I need a clicker here. I love slides, and especially one of these slides that Greg loves, I'm going to put up here and talk about some of the concepts here. So let's see if this works. the CTO of the CIA can get this to work, or not. Anyways, can we advance? Yeah, there we go. So the big picture that I always start with, and I think I start the paper with this too, is to quote Mark Andreessen, and I know this is kind of a cliche thing to do, but it's very, very true. It's super, super important. Technology and software is eating the world. And any industry, any business, whether it be a hot dog stand or the Department of Defense, if we don't take technology seriously, or an organization doesn't take technology seriously, it can get eaten alive. It's both offensive and it touches both defense, and it transforms either of those things in an incredibly, incredibly important way. Vulnerable organizations in general, I talk about, going to Cafe Jacqueline, which is amazing. That's quite I did not know he was going to pull that reference out. But it is, unfortunately, organizations like Cafe Jacqueline that are always vulnerable to the types of scaling and leverage and cost advantages that technology brings to bear. Technology tends to be thought of as a niche kind of, something that is applied or you sprinkle it on later, instead of thinking of it as the main ingredient. When I talk about category-killing companies in every industry, pick anything, finance, transportation, media, every one of those category-killing companies is actually a technology company first that happens to be operating in a particular vertical. And it's that level of intensity and change that I think we need to bring to this effectively part of the economy that has somewhat been immune to the secular changes going on in the world. So that's really sort of the core idea behind this, is we cannot think of this as an afterthought where you build the building and then bring the architect in later to actually deal with things. You have to fundamentally spend the time architecting something as complicated, as important as warfighting and warfighting systems, and the way we actually build our business processes to actually go do this. So that's sort of the core idea here, and if we go to the next slide, this is sort of a diagram in the paper, which I think is really important. So this is I don't want to turn this into a lesson in economics or anything, and I wasn't an A+ student in any of it, and I think Greg and I used to have a lot of conversations and discussions about this, and a lot of this was actually on the General's board that I don't think you ever erased actually for a while. Building, running, and scaling technology is a business function. In Silicon Valley, we train people to do this for years and years and years. One of the key things in government that we sometimes tend to do, or actually what I call sort of more of the buy side of technology, is that we view everything as IT. And when you think of product development versus IT, consuming IT, they're two very different things. One is about buying and deploying packaged technology products at scale, which is a skill. And another thing is actually building and architecting products that we need to build and buy that are custom for us, that you have to have that architecture and skill set almost equally as well as a company that actually produces product at scale. Now, unfortunately, what happens is, because of the way we solve problems at the DoD, or used to solve problems that are no longer there, obviously, was a function-specific model of we take a particular problem, we solve it with a piece of software or tech, and another, and another, and another. And I call this the swivel chair integration problem, or the O6 in a box problem, where you've got you've seen those pictures on the operating, floor of you've got 8 screens and somebody with 8 keyboards trying to integrate data onto a PowerPoint presentation so they can take it to the big boss general, unfortunately 3 days late with, bad information on it. So fundamentally, when you think of scaling and bringing those characteristics, the economic characteristics of scale, you have to end up with an architecture that looks like something on the right. And when you look at the graphs there, on the left is an example of an architecture which is vertically integrated. You end up with average and marginal costs that at best are flat, which is every new application you build, you're effectively paying all the way over for that vertical app. And so your total cost actually just linearly scales with the number of apps, but actually it's worse because the more apps and code you actually deploy, the costlier it gets. So your total cost structure actually is actually going up non-linearly in some way. What you really want is the graph on the right, because technology and software is one of those rare cases, unlike soufflés, where actually soufflés, I guess you do get some marginal costs from buying a lot of eggs and milk and things, but it's marginal. But with software and tech, the more you buy, the higher volume you get, your costs actually go down. Your average and marginal cost should be going down, which means that you get a handle on your total cost control. So this paper, at the core of it, it's not only about money, which basically gives you those cost advantages, but it's about all the things that the general talked about in terms of having that rapid cycle on the enemy and your adversary that tech gives you. So it's speed, it's cost, it's advantage, it's the sort of things that otherwise you can't scale with the human side of it. Next slide here is actually in the paper here. And I'm not going to bore you with all the boxes and all the arrows and everything there. But this is an architecture diagram. This is a blueprint that allows you to start thinking systemically about how all these pieces fit together, and different levels of code and different levels of systems give you reusability and scale. It gives you cost advantages in terms of being able to do marginal app development at a lower cost. And of course, the software-defined set of this, and I think we'll talk about this somewhat, is this idea that today's complexity in terms of hardware, and the DoD is the ultimate hardware organization. And the joke that I have is that Silicon Valley moved on from building hardware a long time ago. We're an asset-light industry. We love people, we hire them, bring in computers and laptops and keyboards, and that's pretty much the only hardware that we have there today. That's all been exported out. But the concept of software defined is moving the complexity and cost and inagility, or I guess, what would the word be? Rigidity of hardware, and pulling that complexity out into software where it can be rapidly changed, rapidly scaled at very low marginal cost. So that's the game that we need to play in some sense. I'm going to end by just one other diagram, which I put together a long time ago. So this is an example of exactly what the general calls, my favorite term in the DoD is JADC2. So this is an example of a very, very large battle network that we need to be pulling together to drive command and control. And what's interesting is when the JADC2 discussion used to happen at the DoD, it always started from, well, the services or a piece of hardware up. And in some sense, the other big piece of this is changing the polarity of the design process and the design piece, which is at the center and at the top is the customer, the combatant commander, who is the ultimate customer and the person who actually is receiving the information and having to make those decisions. And in many cases, it's not only the software architecture, but it's the care and time we spend learning about customers' needs and focus. So one of the things we did at the JAIC at the end was actually inverting the process. Instead of talking to the services first, we actually moved it to actually embed ourselves in with the combatant commanders and the customers. And again, another big revolution that we need to rethink is how we build software. If we're going to build it, we need to build it right. So I hope all of you have either read or enjoyed the paper, and I will finish right there. And again, thank you so much, sir, for doing this, and Greg for hosting us, and CSIS for pulling this together. So thank you.
So now we're going to move into the moderated discussion section. If you have questions, my colleague Akil over there can collect the note cards upon which you should write your questions, and then he'll refer those to me. But I'll go ahead and get us started by just once again emphasizing what a remarkable document this paper is and how privileged we are to have it here published through CSIS. What you have are two of the people who were really on the ground floor of the DoD AI revolution with two very different but equally remarkable backgrounds. A 36-year career in the Air Force and the leader of the flagship AI initiatives in the DoD twice, actually, and also a Silicon Valley entrepreneur who then went to the DoD. And this paper sort of reflects their collected wisdom about what does need to change in the Department of Defense if we want to be the software-defined warfighting organization that we want. So I want to start by asking you about the concepts that are in this paper, because one of the things that I think is so powerful about this paper is that it's not another vague call for acquisition reform, although acquisition reform is needed. It's actually a specific outlining for a different type of architecture, a different approach or paradigm to the management of technology and the concepts that tell you whether or not you're headed in the right way. So could you please, sort of outline some of these concepts that how do you know when your architecture is built for scale? How do you know when you're approaching software in the right way?
Sir.
No, go ahead.
So the first thing to zoom in on is, again, your point about acquisition and procurement. So the reason why I think the conversation doesn't get very far in acquisition reform or other pieces, and that's a broad problem, is when we think of acquisition and procurement in the tech industry, that is actually the last step in what we do to build and deploy and architect and run software, which is the buying part of it, right? Procurement and acquisition is about taking the thing that's there and getting it in. What we fail to then think about is all the front-end stuff that actually goes into the procurement process, which is design, architecture, customer input, all of the considerations in terms of environment, the needs, distribution, failover, all the core concepts in here. And what ends up happening is this procurement problem also ends up with slide number 1, which is one app that solves one problem, another app that solves one problem. Because part of it is also the way we articulate needs to our investors, right? So what tends to happen at the DoD or anywhere here is I've got a problem, you've got a problem, and you've got a problem. I call this the Oprah moment, which is everybody look under their chair and they've got $20 million to go solve a problem. And so it's probably 20 is too little, but that's the core idea. So we need to move and shift away from this idea of thinking about procurement as the solution. For sure we need reform. There are all kinds of issues that we need to deal with there. But truly what we need to do is actually get back to the roots of, I think, what I understood the DoD used to do in the old days, which is we had experts in the fields where we're going to build or buy something and have those experts on the buy side who actually understand how to actually buy, deploy, or build any of this stuff instead of actually outsourcing all of this intelligence out to the vendors there.
And so what I'll add on to that is you asked, how do we know if we succeed? I'm not as capable of answering that question. What I can say is I know when it doesn't work and when it fails. And the reason I know that, because after, almost 5 years of Project Maven and Jake, we knew you would plateau with AI-enabled machine learning, computer vision, NLP sort of solutions. They were bolt-on solutions to legacy platforms, legacy solutions, and they would work, but not work nearly as well as they could work if they were designed from the beginning into these weapon systems. So all of these principles that are laid out in the paper are designed to do things much faster, much cheaper, and be able to be agile. So when Nan talks about who is really the customer here, he's right. We turn to the combatant commands first and foremost. What are your operational imperatives? And how quickly can we get at those through the services or the service providers? But I know when it doesn't work, and we saw what doesn't work. You were there as we would get very frustrated saying we have this very, very current, and some would say leading edge computer vision technology. We're bolting it onto a system that in some cases was built in the 1970s. You just don't get where you need to get. So what can we do differently to make that, sorry, I'm going to use the term seamless, and I'll punish me for that. But what we really should be doing is no more bolting on, but baking these in weapon systems from the very beginning so that nobody even pays that much attention anymore. It's an AI-enabled solution, but it's part of the architecture. That's why we look at this with our different backgrounds, but we reach the same point, which I always find interesting.
one of the ways I recall that you used to sort of explain this in the DoD is imagine if step one for creating any mobile phone application was design the hardware behind the iPhone. And then step two was create the iOS operating system. And then step three is you finally get to start working on your app, right? We would have a lot fewer apps and they would be a lot worse. But in a sense, the DoD forces organizations to do that. They force them to create their own infrastructure, their own platform, their own application, instead of having common infrastructure, a common platform, so that program offices can focus more on the application side of the equation.
And Greg, if I jump in one more on defining success in this case. This is a conversation Nand and I had over and over again. And it took me a while. Look, I don't pretend that I understood all of this even after doing it for 4 or 5 years. But the diagrams he used to draw on the board about, let's remember, what the ultimate goal here is there's somebody on a front line. That front line could be a virtual front line in cyberspace, but a Marine on the ground, say, in Afghanistan. All we should ask them to do is to write an app and take advantage of all the infrastructure that's already available to them. And if it's back in an enterprise cloud, so be it. Sometimes the enterprise cloud is not available because denied, degrade, disconnected environments, but give them everything they need, including the data that's already been through the data management, data cleanup processes, all that work that has to be done. All that person should have to do, he or she, is say, I know what I need. I can do it as quickly as you can give me all the enablers. I'm just going to write an app on top of it. So to me, the paper is about that future. We get to that future, we're in a different world.
That's great. And so the title of the paper is software-defined warfare.
Yeah.
And software-defined it is a term of art in Silicon Valley that folks are familiar with. So what does that term mean, and what does it mean when you apply it to warfare?
Yeah, no, absolutely. That is the core idea here. For those watching who know tech, you've heard of software-defined networking, which is a core concept. But today, for instance, cloud computing is obviously all the rage now. Cloud computing is software-defined computing. All of this actually started, I'm sure the origin stories for software-defined is everywhere. For me, it was about virtualization. So when Diane Green and her husband Mendel started VMware, and this core idea of taking hardware and software and disconnecting them. So for the first time, you disconnected an operating system and applications from hardware, and you turned basically the entire machine into a virtual machine. That was the first time when all of a sudden you can now manipulate and change an actual computer system with the agility of a command line and hardware. And that sparked a revolution in pretty much everything that we're dealing with now. Cloud computing, everything, all of it owes its origin to virtualization. But then what happened is this idea of taking, virtualized operating systems like Windows and moving them into the cloud, everyone started thinking, well, we have this entire 8, 10, 15 gigabyte image that contains all this other stuff. Let's slim it down. And once you started doing that, and you change your application architecture on top of it, you ended up with exactly the stuff that the general pointed out. We call this obviously pets versus cattle, horizontal versus vertical scaling, and then all of a sudden you end up with containerization, which allowed for each container to be a compute node. So this whole idea of, once you virtualize, you change your architecture, you change your scaling characteristics, you build platforms, you then get things like Kubernetes, you end up with containers. All of this stuff, it's an evolution. It's been a 10 to 15 to 20-year evolution that we've had in the tech industry for moving from one point to another. But at the end of the game now, when you actually look at a highly skilled internet scale set of applications or suite, a lot of them, it's all software-defined. It's software-defined programming, software-defined deployment, software-defined scaling, software-defined networking, software-defined storage, software-defined compute, software-defined application development, updates. Everything now is programmatic. So we call this infrastructure as code because you've now taken infrastructure, which used to be about manually touching hardware, and effectively codified it. And once you codify something, then you can program it. And we know how to do programming at scale. So this is the core of it, which is how do we take this hardware-oriented organization, pull the logic and the workflows and the kill chains into software, and have every element be a programmable element with an API and some amount of scaling, all of a sudden now you have an orchestratable warfare as code. I guess we'll coin that term today. It's warfare as code type of a model where your entire infrastructure is now fully reprogrammable, exactly the way the general was pointing out.
And I'll take it up to a non-technical level. When I told someone the title of the paper, I didn't send them the paper because it wasn't out yet, but the title of the paper, I got the equivalent of a raised eyebrow on email. I'll just put it that way. Software-defined warfare. That's a bold statement. My answer was along these lines. If we had called the paper software-augmented warfare, it would have been met with a collective yawn. Software-defined warfare is going to get some attention, and it should get some attention. Now, I want to say one thing that we make clear in the paper, and please, I hope everybody will appreciate what I'm about to say. This is a technology paper. We never claim for any moment that the human is gone or that hardware is not important. This is about making the hardware better, more effective, more efficient, more economical, more ability to scale, more agile, and that people get to do the things that people are best at, especially on the cognitive side of the house. Let the machines do what machines do best. You can't do that with the architecture that we have built today, as we learned from both Maven and the Jake. So this is not technology at the expense of people. It's letting people do better with what they have available to them.
That's great. And just as a reminder, if you could, if you have those note cards, you can just pass them to the ends of the rows, and Akil will come pick them up. So what you just said is a great sort of segue to this sort of basic insight in the paper about the importance of economies of scale, where if you want to go from making 10 widgets to making 20 widgets, you have to double your cost, but if you want to go from 10 widgets to 100 widgets, you should not 10x your cost. You should have some kind of positive returns to scale where the marginal cost goes down as you do something more and more. Well, the DoD is pretty big, right? I mean, it's about 1 out of every $25 in the economy is the DoD. It's the largest organization on earth in terms of how many people work for it. And so what is it about the DoD that makes it so hard to achieve good economies of scale?
Well, I'll begin by the obvious one. We've seemed to be, I hope, coming full circle. So we started, say, in the 50s and 60s with this idea of quantity, cheap, in some cases disposable. And we got to a point, say, in the last 25 years where exquisite, very expensive, very limited numbers of it. Take aircraft carriers, take submarines, take B-2 bombers. You only have so many. And in a fight of counterinsurgency, counterterrorism in the Middle East, not a problem. In a potential fight against a peer competitor, a big problem. And I remember the discussions during the early days of Desert Storm talking about attrition percentages. 5%. 5% may not sound like a lot on day one. It's an awful lot after day 20 of the war. And that's what we're facing today with exquisitely expensive weapon systems that are exquisite, but there's only so many of them. So we have got to get to economies of scale and make the marginal cost much lower for the 100th version of the widget rather than the first. Anybody who's watching what's happening in Ukraine today, I hope appreciates that we're seeing a future play out in real time of small, attritable, swarming capabilities. At some point, there's a chance there will be AI-enabled capabilities, and we're not necessarily prepared for that because our architecture doesn't allow us to build that quickly. People are doing it because they're innovating on the fly, in minutes in some cases. But as a DoD, we're not set up for that. So I'll not anything else on that.
No, that's absolutely brilliant. I think part of it is, so in the DoD, so I think we were talking about this earlier about the Netflix example, right? Which is, at any point in time, there is an aspect when we look at technology companies or the technology industry, there's a huge case of survivorship bias, which is we look at these incredibly scaled multi-trillion-dollar companies that we see, and we obviously try to say, great, this is a great company, et cetera, but we also don't realize that there was an entire Darwinian process, decades long, that led to these companies being successful, the ones that got chosen to be successful. And we forget all the 400, 500, thousands of companies that are now litter the battlefield, and this one emerged out of it. Now, not to take away from it, but those companies effectively have a reset button that gets pushed every time there's a failure of a previous generation company, you can kind of clear the infrastructure and start from there. To the Department of Defense's, and I think in general government's defense, is, no pun intended, is we don't get a chance to have that clear-cut process where a forest fire burns through and new growth comes in. So here we are with years and years of accumulated technology debt and infrastructure, and it's very hard to say, great, we're going to reset the button and get this investment to come in and clear-cut it. That's one. And then there's all the additional problems of the procurement problems, laws and regulations that are put in place for good reason, which are things like corruption and graft and selecting companies that are, et cetera. I mean, there's all kinds of rules and regulations. However, we also run in the trap of what I call Stockholm Syndrome, which is because these rules and regulations concerning things like procurement, who to buy, how can we talk to vendors, work with them. When I'm in an engineering, running one of my startups, my VP of engineering is sitting literally right next to me. And that level of engagement between the sales team, the customer team, the product teams enable you to build great software. We're stuck because on the government side, we actually have all these good rules and regulations that are there for a good purpose, but they hinder this problem of being able to build great software. I can go on and on and on of other things too, which is information gap, skills gap. In many cases, we're taking people who otherwise are not domain experts in tech, all right? Now, it's one thing for the boss to be there in terms of the domain expert who's managing the business, but people who are actually writing code and doing product management, you remember the time when we actually created a title called product manager, and we actually had to go to the HR team to set up in the mainframe a product manager title. And it's incredible because here we are building code and software and tech and not have product managers. So it's a huge, maybe this is our next paper.
Well, there wasn't a GS code that said product manager.
GS code, right, exactly.
You can't do it.
But yeah, it's a obviously super, super complicated problem.
Because the job title product manager did not exist in World War II, we're just never going to do that.
We're not going to have any product managers.
I mean, that's when we designed the HR
exactly.
system. It's,
Now, telegraph operator.
Telegraph, that's right.
No
it is true. In the way that the DoD tracks all of its government spending is by something called product service codes, PSC codes. I hope most of you don't have to encounter this data set before your life. But anyway, there's nothing there for computers. It's called automatic data processing equipment because when they created the codes, that's what was there. They can use computers. Akhil, can I get the questions from the audience? Nand, I know you're here to talk about your paper and your time in the DoD, but I didn't want to let you get away without saying nothing about your incredibly cool new job as the Chief Technology Officer for the CIA. And so could you just talk a little bit about, you're the first of this new position. So, why did the CIA create this position and what are you excited to work on now that you have it?
Okay, great. Let me see how much I can talk about without giving away
Somebody will
top
tackle
secret
him,
information.
as soon as he, yeah.
Well, I got to start by saying it is truly the coolest job in the world. And my 15-year-old, when he told me that, I was like, okay, great. I'm finally worth something. The confusion around the CTO title might be, the CIA must be behind in tech, and therefore they need to catch up and do this and that. It's exactly the opposite. There are two really big things here. One is the breadth and depth of tech at the CIA is truly, truly unbelievable. This organization obviously can't do what it actually is tasked to do without having that level of game. But the problem is that the tech is so wide and so distributed, and the mission for the agency, and this is one thing that I found in my couple of months being there, is the agency knows how to move and move fast. But in that, what happens is the focus is on the mission and getting the job done. And it really isn't about a focus on, we're going to go clean all this up and build this and that. There are parts that are enterprise scaled, internet scaled to a point where it rivals the best in Silicon Valley. And then we also build things like, a one-off unit of a shoe phone. Is what I call. So it's bespoke tech all the way to scale tech. The job actually for the CTO really is focused on two core things. Number one is technology as a domain is now becoming incredibly important, right? as a industry for us, as a country, as a domain of competition, it is becoming the core piece there. So as an intelligence agency, it's incredibly important for us to embrace that and own that. Our business needs to extend out to learning about it, knowing about it, and being part of it. And the second is all the great stuff that we talk about in the paper. Silicon Valley, the technology industry, is evolving at an incredible rate. And venture capital, it's been a revolution over the past, from back when I started my first company in 1996 to now. Even the way technology gets invested in, the platform, it's the classic curve, which is just the rate of change has gotten so good that we as an agency, and I think government writ large, needs to learn better how to harvest those benefits and get on that curve. So it's actually a pretty simple piece. Director Burns has made technology one of his top priorities, and the creation of the new mission center around T2MC, the CTO role, is a direct reflection and action that he's taken on this. And he is just an incredible leader in terms of driving change. CIA turned 75 this year, which is an amazing milestone. But it also actually is kind of a mark which says, great, what does the next 75 years look like? And a lot of it, I think, is going to be tech-driven.
That's great. So now we're moving to the questions from the audience. And so one person points out, even the most mature technology companies at the absolute highest scales still occasionally suffer from critical infrastructure failures. So what should the DoD take away from that? Is there a posture towards failure that they need to have? And I know some of this is covered in the paper with your discussion of Chaos Monkey. So
yeah, let me start. And
please.
Get a little bit more on the technical side of it. It has to be the entry point, because the first question from anybody when you say, okay, here's our proposal for an architecture, the question is going to be, how will it do in a fight against a peer competitor? In that jam, disconnected cyber, all that has to be into account. What we've laid out in the paper, thanks to sort of Nan's presentation of doing so, is this is what we're getting at here. It has to be resilient. You have to build in. I'll use the term. I think some people don't quite understand it, and maybe I don't enough, but the idea of anti-fragility, that you build it to design that it will operate even better when it fails. That's a hard thing to get to. It's a concept that means one thing sort of theoretically, but then to put it into an actual architecture. But the idea of a combatant commander saying, that's a great architecture, but what happens when? And you're going to get 1,000 questions about when. What Nan brings up in the paper, and I think an especially important point, is the idea of Chaos Monkey. Testing it, experimenting with it, wargaming with it, pulling the plug, seeing where the architecture falls apart. And then, can it operate in a disconnected environment? And if it does operate in a disconnected environment, can you then reconnect it once the environment is permissive? But we agree. In fact, we couldn't agree more. And I think the paper is designed with an architecture that allows that sort of scenario. What I worry about now is, you know it, I know it, Nan knows it. Nobody knows what's going to happen sometimes when something fails, because the architecture is a mess. Because nobody has a handle on every bit and piece out there. So if we don't do it, I'm actually more concerned about that future than if we do build towards this architecture.
I don't think I could have said it better. The only thing I'd add is we are now, the experimentation with things like Chaos Monkey simply cannot be done in a physical world. You're not going to have two of Maverick's, planes there, and one to test with and one of them to fly. It's, you get one plane, and you can't...
Can you just elaborate a little bit about what Chaos Monkey is?
Yeah, absolutely.
Familiar with this?
So Netflix obviously was one of the pioneers in this newer generation of companies. Now, obviously, Netflix is old news, but back when Netflix was one of the first companies to adopt AWS, right, EC2, as the core platform, it was revolutionary. This idea that they wouldn't run their own data centers and they would outsource this to Amazon and do all this stuff. Now, of course, the story on infrastructure has changed, where they run part of it on premise, part of it scaling on the cloud, but those architectures settled there. However, they also pioneered the architecture around things like microservices, which is taking a big application and decomposing it into smaller and smaller pieces. So that instead of one big giant monolithic piece of code, you break it up into smaller pieces. And because of that, and we cover this in the paper, is things like interfaces or APIs allow you to then independently evolve each function so that your entire code base doesn't change when you make one change. Now, what Chaos Monkey was is the testing team basically said, well, we've got this incredibly, incredibly complicated architecture. It's highly distributed, scaled, et cetera. How do we test it? Well, you do things like unit testing, functional testing, which is the usual stuff. And they said, well, what if we start, how do we simulate random things happening? And they came up with the idea of a monkey letting a monkey loose on a data center. And what it would do is just basically start ripping wires and throwing boxes around and doing all kinds of monkey stuff. And they called it Chaos Monkey, and they open sourced it. Nowadays, obviously, Chaos Monkey, they're better products and things like that. But the core idea of running kind of a Chaos Monkey on your infrastructure, a digital twin infrastructure, is something that we cannot do in physical land, because you're not going to let a monkey loose on an F-16 or an F-35, hopefully. But that's the core idea. So this idea of when you move it to software, your cost of building a digital twin and testing it for scale and other pieces there becomes dramatically easier.
I mean, I think it connects to sort of two big ideas in the paper. You know, the DoD loves to have red team type of analysis, or even, in the cyber world, penetration testing, where some good hackers who work for the DoD will hack other parts of the DoD to sort of assess whether or not they're good. Netflix Chaos Monkey is going above that. No, we're not even going to make somebody have to figure out how to hack your system. We're just going to give them God-level privileges, and we're just going to break your system. And so you have to figure out how to continue executing your mission, even if big parts of your technology stack are just objectively broken, whether that's from us pulling the plug or something else. And that's a different paradigm of resilience.
It's scary for people.
Exactly. And so, you don't want to do that on a nuclear submarine. I don't recommend just randomly pulling wires on a nuclear submarine. But if we had this digital twin infrastructure that you recommended in the paper, we could run those types of simulations and have the insights that those would generate. Okay, so the next question is about small businesses. And I think we've all seen this, right, where any kind of delay in the government acquisition process, it's painful for a big, government contractor, but it's really painful for a small business. And so there's been a lot of work to focus on this. What do you see as important to think about for the software side of the ecosystem, where small startups have been a big factor in Silicon Valley? Does the government need to be doing something different? Does the Defense Department need to be doing something different than all the initiatives that we've already launched?
Yeah, I'll say something on this, and I know Nan, having come from that, will have more to say. But the philosophy we took from the very beginning in Project Maven, that I carried over with me to the Jake, not without some resistance, was a commercial first philosophy. And Greg remembers, and Nan and I used to talk about this. In those early days of Maven, our deliberate strategy was to go out to small startups, not the big defense industrial-based companies, because one, they didn't have the things we were looking for, computer vision and NLP, but small companies did. Very hungry, very enthusiastic, very aggressive small companies. But that was also a little bit of a signal to big companies, we're serious about doing this. We're going to put money behind it. Everybody's an equal player. And when I say everybody, I mean a 10-person startup was at the table, just as Google was eventually at the table on our wide area motion imagery sensor project. And we carried that over, not always with great success, because once you start going to scale, you have an umbrella contract where maybe there's an integrator trying to bring a lot of different companies in. That's a little frustrating for some of the smaller companies. How do I get in on that? We did have a process, but it's a difficult process. I know there's a frustration with, say, the CIBR process, where a company may get that first $50,000 and think that life is great for the company, but a year that CIBR runs out, they don't get a stage 2. And they're not only frustrated, they don't want to work with the government anymore. Throw on top of that the frustrations with just working through security clearances, acquisition and contracting, and it can be extremely frustrating. There is some silver lining, which is there's a lot of focus both on the Hill and in the department. Let's do better at this. There are ways to move faster, and we did a lot of those, both in Maven and Jake. You have a lot of latitude within the Defense Federal Acquisition Regulation, more than some people realize, but it's not perfect. Definitely not perfect, but there's a lot of latitude to include allowing small companies to come in and compete in a very Darwinian process that Nan talks about, I think, opening in the paper. Look, this is a competition. May the best win. If that best win is a small company, fantastic. Nan, you probably have more to say about that.
Yeah, just to extend, we could spend a couple hours on this stuff, because not to call this a blame issue, but the configuration of the sell side and the buy side is not great. Okay, so let's look at it from both sides. On the buy side, if we're buying packaged products to deploy at scale, that's an easy one. We should be thinking of products that are delivered at scale, et cetera, but then the characteristics that the general talked about in terms of security clearances and running it on the high and the low side, and other things come in. But we should be able to buy and deploy packaged products at scale. The problem, though, is that things like the Defense Department, in many cases, we're a monopsony. We're a buyer of one. And a monopsony issue really causes a bunch of problems because there isn't a robust market for those products where you've got hundreds of companies competing for selling to one customer in a particular area. The reverse side of it, so let's flip to the sell side of it, which is these companies that are building products. As a former CEO, I was not building widgets. I was building products that I wanted to sell at scale, unlike Cafe Jacqueline, with zero or low or zero marginal cost at very high volumes. That's my game. That's what a VC invests in. That's what a company wants, is small numbers of products at very high volume and incredibly large margins. That's a business. The problem is that what the DoD needs in many cases is, I have an existing system or a process, and I want to take a component of IP from you and plug it into my system there. So first is the company itself doesn't want to widgetize it. In many cases, it's not widgetized enough, although that is changing. This is the AI piece that the general talked about. Is one of the products that we ran projects was Project Zalus, where we had a platform, and this is the other side of it, which is on the IT side and our side, we're a bad customer because we don't have the infrastructure to take a widget and run it. And so just the configuration and friction of commerce is there. But in this case of Salus, for instance, what we did is we architected the system in the right way, where we had a data platform that we, the DoD, owned and operated, built by obviously a vendor. We didn't build it ourselves. And then we had it's like a generative platform where you can have multiple companies throwing their applications on top, and it became a process of elimination. So we had everybody come in and either drive different functionality or compete for the same functionality, and it was the best one that we kept on going with. And so once the architecture got done right and the components were ready, that's where the magic started happening. And that's where that architecture comes in. When you disconnect these platforms, you build it as open APIs that allow for multiple people to compete without, what I call it, without tolls, without gates, without actually friction. You end up with the economics that you're really looking for on the other end.
Yeah. What you just heard is, Nand talk a lot about the challenges of what it's like to try and execute in the DoD. And I remember one time, Nand has founded and sold many companies at enormous returns, to his investors and building great technology. And I just remember very vividly one day he was like, there's a lot about working in the DoD that's quite a bit harder than working in Silicon Valley. And to his credit, he continued government service and wanted to go after the hard problems. So we're almost out of time here, but General Shanahan, you have had an incredible seat to witness this transformation, right? You were a whizzo in fighter aircraft for a long time. You were in charge of FISRA, the Air Force ISR agency, which was sort of the first part of the Air Force to encounter the big data problem, collecting petabytes of ISR data. Then you were in charge of Project Maven, the sort of flagship AI initiative. Then you were in charge of the JAIC, the flagship AI DoD-wide AI initiative, not just ISR. And now, you're frankly a scholar, analyzing these issues from the outside, and a part of the warrior scholar tradition of the United States Air Force. So, what can you tell us about where the DoD has made progress and where there's still the biggest challenges that need to be worked upon? And obviously, the paper is the real way that you should get this answer, but General Shanahan.
Well, I'd say sometimes you're fortunate to be, all of us, at a certain point in history, and sometimes we call them inflection points, but they're really inflection errors or epochs, which may last a century as we make this transition from an industrial age to a digital age. It's not going to happen overnight, but you see it and you get excited by it. And we're in a place now where you get probably on most days equal hype and equal doom. I believe the reality is definitely in the middle, and we cannot look 20 years in the future and hope we're going to succeed in whatever fight that's going to be without doing a redesign of the architecture. We're in trouble if we don't. And none of us like to see failure being the only reason that you drive change. So with that sort of as the backdrop, I believe we are now in this time of transition, at least beginning, however long it plays out. But I'd say what has worked in between Project Maven and the Jake is the beginning of a culture change. We show you can do remarkable things in timelines that everybody thought was impossible. To be honest with you. I mean, there is no way you're going to have 4 companies on contract at the beginning in 4 months and have them producing products in 6 months delivered to a combat zone. So it can't be done, not under DoD rules. We did it. And then similar in Jake, you cannot do that in that timeline. But that means people feel differently about what they're doing. They're excited about doing it. So it is a beginning of a culture change that showed this and many others. Kessel Run, AFWorks, SoftWorks, Air Force, MIT Accelerated, Naval X. I mean, there's lots of these that are beginning and have been sprouted for the last few years. What hasn't happened yet, so on the bad side, is there's still one-offs. Even Maven, to an extent, is a one-off, but that's going to transition to NGA, and I hope that brings sort of those changes to the entire intelligence community, defense intelligence enterprise. So on the good side, we know what needs to be done now. There's no way that paper was being written 5 years ago in the Department of Defense, because there were too many other things to focus on with the IT infrastructure. But now there are a lot of people that are thinking along these lines. What Nand has done is lay out the framework for doing it. So it's there for the taking. Now we actually have to implement it. So there's a part of me that's very excited, more excited than ever, that we see a future coming that we can adapt to. There's a part of me that says if we don't do it, if we don't bring this culture change across the entire Department of Defense or across the United States government, then we're in trouble in a future fight. So there is an imperative to do this. And I know we talk about happening overnight. It won't, but there's no better time to get started than right now. It is exciting, like I say.
Well, ladies and gentlemen, you've just seen some remarkable thinking from 2 of the most extraordinary leaders in the national security technology field. So please join me in thanking our presenters today.
Thank you.
And the paper is available for download at csis.org. So I hope you'll all read it and take the time to digest the insights within. Thank you all. Have a wonderful day.
Thank you. Thank you, Greg.
Thank you.
Thank you, sir.